Welcome to the Explainer. Okay, let's dive right into this. Today, we're unpacking a really robust, project-based fifth grade science and math curriculum called the water filter. If you're looking for a way to get your students actively thinking, arguing from evidence, and literally applying their math skills to a real-world science scenario, well, you are in the right place. It's totally fascinating to see how this 3-day mini-mission is structured, so let's get into it. Right off the bat, the mission's tagline is really the beating heart of this whole curriculum. Protect the town's water with the data, not one number. I mean, think about it. How often do we see students, and honestly adults too, just grab onto one flashy metric? Like they see the cheapest price or the biggest raw number, and boom, they make a snap decision. This curriculum is passionately designed to break that exact habit. It's all about teaching kids to look past those surface level metrics and really dig into multiple layers of data. Here is our quick roadmap for today. We'll be covering beyond one flashy number, day one's balancing criteria, day two's fair test, day three's long run, and finally, assessing reasoning. Section 1, beyond one flashy number, setting the stage. So this mini mission is built specifically for fifth grade, focusing heavily on science, matter, properties, engineering design, all that good stuff. It spans exactly 3 roughly 45-minute class periods and works beautifully for groups of 3 to 4 students. And what's absolutely fantastic here is the tight alignment with next-generation science standards. We're talking analyzing properties of materials and understanding fair tests, but simultaneously, it's pulling in 5th grade decimal math standards. It is just a seamless, cross-curricular experience. Section 2, Day 1, Balancing Criteria, Finding That Sweet Spot. All right, picture this for day 1. The foundational setup is that the town needs a new water filter, but obviously there are strict engineering constraints. The kids are told they have to find a filter that removes at least 8.0 grams of mud, so it has to be clean enough. It also has to flow at least 2.0 liters per minute, meaning it's fast enough. Oh, and it must cost no more than $50, so we're staying within budget. They basically have to juggle all 3 of these requirements at the exact same time. Now, when they actually look at the data for the 4 different filters, a student might instinctively spot that super filter up there. It removes a massive 11.0 grams of mud, so they might just pick that right away. But wait, the flow rate is only 0.5 liters per minute, which completely fails the 2.0 requirement. Plus, at $60, it's over budget. Or, another kid might grab the quick flow because, hey, it's only $30 and flows super fast. But it only removes 5.0 grams of mud. The water wouldn't even be safe. And the eco filter? Fast and clean, but it costs $55. So by guiding them through this, students realize that the fine mesh is the actual winner. It removes 9.5 grams, flows at 3.0 liters, and costs $40. It's literally the only option that passes the holistic test. Moving to Section 3, Day 2, the fair test. This is where we catch the uncontrolled variable. Let's see how this builds, because on day 2, a new dilemma pops up. A salesperson rolls in claiming their Clear Pro filter is way better because it removed 12.0 grams of mud. And yeah, 12 is obviously a bigger raw number than the fine mesh's 9.5 grams. But, and this is a big but, the students have to check exactly how that test was run. Fine mesh was tested on water with 15.0 grams of starting mud. Clear Pro, it was tested on far dirtier water, starting with 20.0 grams of mud. The kids have to catch this unfair, uncontrolled variable. You simply cannot compare those 2 raw numbers fairly. Now, what's really interesting about this is how the curriculum uses math to solve the science problem. To find out which filter actually works better, students have to calculate the share of mud removed. So they take the mud removed and divide it by the starting mud. For fine mesh, 9.5 divided by 15.0 gives us 0.63 share. For the new Clear Pro, 12.0 divided by 20.0 gives us a 0.60 share. The math completely proves that the seemingly better filter actually removed a smaller share of the dirt. It's such a massive light bulb moment victory for the kids. Section 4, Day 3, the long run. Let's look at the true cost of clogging. So, now we're in the final phase, and students get a month-long tracking table. Remember, to keep the town's water safe, the filter has to remove at least 8.0 grams of mud every single week. We are tracking our initial winner, fine mesh, against a slightly more expensive option called Pro Mesh. Look really closely at week 3. The fine mesh filter's performance drops to 7.0 grams. It's clogged. It just dropped below the safety requirement. Meanwhile, the Pro Mesh stays highly consistent, never dropping below 8.2 grams for the entire month. So, the crucial point here is the concept of true cost. If the fine mesh fails in week 3, well, the town has to buy a second one just to make it through the month safely. That means $40 plus $40 equals an $80 monthly cost. The Pro Mesh, which initially seemed way too expensive at $55, lasts the whole month. The ultimate aha moment for your class is realizing that the initially more expensive filter is for sure the smarter, safer, and cheaper long-term dye. Section 5. Assessing Student Reasoning. Grading the Judgment. Now, you might be wondering how you actually grade all of this. The assessment is heavily structured. You aren't just grading whether they picked the correct filter at the end. You're grading the reasoning itself. The rubric looks at 4 things. Did they analyze the data and do the decimal math correctly? Did they balance the competing criteria of clean, flow, and cost? Did they successfully catch the unfair test and read the month-long trend? And finally, can they defend their call using actual numbers? This proves you're assessing rigorous, standards-aligned critical thinking. I also want to quickly highlight the built-in differentiation here. The lesson comes with these scaffolded pages. They are essentially heavily supported versions of the daily checks. For example, the math division might be pre-set up for them, or they might be given sentence frames to help write out their defense. But the beauty of it is that it never sacrifices the core integrity of the lesson. The actual scientific judgment and the critical thinking, that is kept entirely in the hands of the student, which ensures accessibility for all the learners in your room. We wrap up day 3 with a capstone reflection, asking the students this vital question. How did looking at the full data help you make a better choice than going by one impressive number? It literally asks them to cite a specific example where the best-looking result turned out to be the wrong choice. I mean, in an age of misleading headlines and out-of-context statistics, isn't teaching our students to systematically question the numbers the most important lesson of all? Think about how you can bring this level of critical thinking into your own classroom. So, what does this all mean for the future of your students' scientific reasoning? Let's keep exploring.